The Allied armies used a mine flail, a tank-mounted device during World War II, to make a safe path through a minefield by deliberately detonating landmines in front of the tank that carried it. The mine flail consists of a number of heavy chains ending in fist-sized steel balls or flails that are attached to a horizontal, rapidly rotating rotor mounted on two arms in front of the tank. The rotation makes the flails spin wildly and violently pound the ground. The force of a fail strike above a buried mine mimics the weight of a person or vehicle and causes the mine to detonate, but in a safe manner that does little damage to the vehicle. Shortly after the start of the war, the German engineers also began to work on special vehicles. The first prototype was the Minesweeper 3, a mine-clearing vehicle based on a Panzer III chassis with a very highly raised suspension. The basic idea was that the extended suspension was used to roll over the mines, and the lengthened torsion bar arms would be capable of withstanding the blast. However, in reality, the average anti-tank mine would cut off the track pins. So, instead the bar at the front was used as the connection for two heavy steel rollers. Only one prototype was built, which was not used in combat. However, despite the failure of the Minesweeper 3, the German troops still needed a vehicle to pass the minefields. In early 1940, Krupp, Germany's #1 weapons manufacturer during both World Wars, began working on a new Minesweeper design. This machine was supposed to neutralize enemy mines by hitting them with their own wheels. Basically, this design combined the roller troll and its tractor. The project received the designation Schweres Minenräumerfahrzeug, or Heavy Mine Clearing Vehicle, or Räumer S for short. The four-wheeled machine had a total weight of 130 tons. The length of the machine was more than 15 meters, and the clearance exceeded 1 meter. It consisted of two identical halves connected by a massive joint. Each half had one Maybach HL90 engine to drive, and each had a cab with its own driver. This allowed the crew to change the direction of movement of the vehicle fast and easy. The structure was welded from massive armor, which was to withstand the impact of ordinary artillery ammunition. The wheels were all steel with solid rubber plates mounted around the perimeter, which partially replaced the tires. The front pair of the wheels had a larger wheelbase than the rear pair to create the widest possible strip of clear space. Behind the relatively wide front compartment, the hull noticeably narrowed and reduced its height, which was done to properly position the wheels with the required track width. The central part of the Minesweeper module contained the transmission units. Under the bottom of the main part of the body, there was a large casing covering the axle of the wheels and associated units. Such a layout of the transmission and the undercarriage allowed the axle to be lowered to the level of the lowest part of the armored hull and thereby maximize the clearance of the vehicle. To connect the two modules of the machine, as well as to control the course and compensate for unevenness of the supporting surface, an original hinge mechanism was proposed. The principle of the combat operation of the demining machine was simple. It had to go to the enemy's minefield and ride it. Due to the high pressure, the large wheels should crush and destroy the mines or provoke their detonation. In the event of an explosion, the undercarriage and hull design was supposed to protect the crew and units from the shock waves. Then, after passing through a minefield and making the passage, the vehicle could simply go back without turning. To do this, the control was transferred to the driver in the rear cockpit. After the passage of the Krupp Räumer S, there should have been a track about 3.5 meters wide, consisting of two relatively narrow lanes. But at the same time, an uncleared area remained between the bands, which could be dangerous for equipment and manpower. According to various sources, the first and only prototype was built in 1944. Soon after, several tests were carried out in the field. The results are unknown, but the Minesweeper was not recommended for commissioning. Probably, the German army was not satisfied with the features of the new machine, which could seriously hinder its operation. The Krupp Räumer S was unacceptably large and heavy, which made it difficult or nearly impossible to operate. The 130-ton machine could not move on its own. For transportation, it would have to be disassembled into a mass of component parts, which could seriously impair the mobility. Certain problems could arise during the neutralization of anti-tank mines. When relatively powerful ammunition was undermined, there was a noticeable risk of damage not only to the wheels, but also to some elements of the hull. In this case, the characteristics of the Minesweeper could seriously fall, up to the impossibility of continuing the work. Also, the survivability of the machine on the battlefield caused some doubts because of its very large size. Such a minesweeper advancing on a minefield without any weapons could easily become the number one target for every enemy artillery piece. At the same time, stopping the vehicle during trolling made the passage already made useless. In addition, evacuation of a damaged minesweeper was also nearly impossible. According to the results of testing the single prototype, it was decided to stop all work. In its current form, the heavy demining machine had no prospects and could not be put into service. So the prototype was returned to the factory, where it was kept until the end of the war. The Allies found out about the existence of the Krupp Räumer S project only in the spring of 1945. At this time, the Minesweeper was at the plant in Hillersleben, where it became a war trophy of the US troops. After detection, the vehicle was studied and some conclusions were made. Due to the lack of documentation, specialists had to limit themselves only to the most general estimates. Apparently, the assessments of the American experts were far from positive. Later, the US Army tried to transfer the prototype to the United States and began moving it to the English Channel. Here, the tracks are lost, and other information about the fate of the machine is unknown. But the German engineers and their foreign colleagues did not try to create such systems again after the war. I hope you enjoyed this episode, and to make sure you don't miss my future work, please make sure you are subscribed to my channel and press the bell notification button. Thank you, and see you in the next video.